just seen the tip of the iceberg regarding the amazing researchers, and research tools. Makes me wonder, though, what other new technologies are under development for reducing icing hazards. But you know what? Now's the time to put you to work. Coming up is a high school student who has spent the summer at NASA Langley in a 9-week mentorship working closely with Tom Yeager. John has prepared a special hands-on, minds-on activity which a group of students will demonstrate. Following the program, you are encouraged to replicate the same investigation.
I spent 9 weeks in a NASA program for high school students called SHARP. Under this program, I had the opportunity to work with Mr. Yeager. I learned a great deal about the research being done on runway friction, tire designs, and new types of runway surfaces to minimize bad weather effects. I have to admit, I was a little nervous at the beginning just because I wasn't sure if I knew enough math and science to be able to grasp the research and to be able to help out in the evaluation of the research data. But I did okay. I found that the math I had taken in middle school and high school gave me a good foundation that I could build on. With the help of 2 undergraduate students that I worked with during the summer, Brian and Jonathan, I have a simple experiment that I would like you to try. In this experiment, you will investigate how surface conditions influence the coefficient of friction between 2 surfaces. Your surfaces will include a ruler, sandpaper, and objects found in the classroom. Now, my friends and I did an experiment similar to the one you're about to do, but it was a little more complicated and involved a little more math. This experiment has been recreated on the Connect Plain Weather website, so you might try this with your friends or your family following the program. Enough said. Let's get started. The math formula you will need in doing your experiment looks like this. Friction coefficient equals height divided by length.
The following materials were collected for our experiment. 3 metric rulers, at least one of the rulers had to be plastic, a sheet of sandpaper large enough to cover a ruler, and 4 objects to test: a rubber eraser, a large metal paper clip, a plastic film canister top, and a small dice. John helped us identify the dependent and independent variables for our experiment. The independent variable, which is what we would be changing, is the ruler surface. We used a plastic ruler to simulate a smooth runway surface, and then a ruler covered with sandpaper to simulate a rough runway surface. The dependent variable for the experiment was the classroom object. Before doing our test, we talked about how each object was alike and different. We shared ideas on how the surface condition, which we would slide these objects across, might affect the friction force of each object. We hypothesized about the effect the surface change would have on the objects. Here are our test procedures we followed. 1 metric ruler we identified as the test base and labeled with the number 1. It would be used to measure the length. A second ruler labeled with a 2 was held upright for the test. We would measure the height from this ruler. The third ruler, labeled with 3, was plastic and would represent the runway. 1 person handled the runway ruler, 1 person held the height ruler, a third person was responsible for reading the height and base measurements, and the 4th person was responsible for recording data. In running our 2 surface tests, we were interested in collecting the height measurement for the vertical ruler and the length measurement from the base ruler at the point when an object began to slide down the runway ruler. We tested each object 3 times on both a smooth and rough surface. The smooth surface was the back side of our plastic ruler. The rough surface was sandpaper attached to the ruler. Here is a diagram to show you how the experiment worked. Each test object was placed at the end of a ruler, and then one end of the ruler was slowly raised. We stopped raising the ruler when the object started to slide down the slope of the runway, and then took our measurements of height and length. Now that we have finished our testing, we are ready to look closely at our data. First, we will calculate the height and length average for each object on each of the surface types. Using these averages, we will apply Jones' formula to find the friction coefficient. That formula is friction coefficient equals height divided by length. Now we are ready to answer our question. What effect does surface condition have on the friction coefficient between two surfaces? Well, this is our experiment. And we leave you with a challenge. What other variables can you think of to test in this experiment?
Okay, gang, you've received your challenge. Complete your own runway traction experiment and then do further tests on different surface conditions. As we bring this program to a close, let me remind you to check out the Connect website for responses from a variety of experts to questions posted throughout this program, and also to participate in an online friction experiment. Let me slide things to Van now for some closing comments. This is Shelley Canright for Connect, connecting you with real science and with real scientists in near real time. Take it away, Van.
Thanks, Shelley. I hope you all have a plain understanding of plain weather. I know I sure do. Join us for other Connect programs. Simply access our Connect website for our information and program availability. So until next time, stay connected.